have fitted with eye bolts, especially in the engine room where you want to lift this cylinder head or cylinder cover and all this. You have a eye bolt that is actually comes with the manufacturer provided all these lifting bolts and all this. So just watch the design of the eye bolt.
Get a real-time bird's-eye view of your projects. Create project plans in one click.
There are 3 basic designs of eye bolts on the market, and in addition, some specialized products. Dynamo, collar, collar with link. Dynamo eye bolts are not recommendable, as these will bend and get damaged at any angular pull applied. They can only be used for absolutely vertical lifts. For vertical lifts, use collar eye bolt rated 60% higher than linked bolt. Lifts between 0 and 15 degrees. Any of the two rating is equal. Lifts above 15 degrees. Use linked eye bolt rated higher than collar. Before you use an eye bolt, you must make sure that the SWL of the eye bolt is adequate for the lift. There are no cracks, wear or deformation of the eye bolt. There is no damage on the threads of the bolt. The threads in the tapped hole where the bolt will be fitted are in good condition. Always apply the load in the same plane as the eye. Screw the bolt tight so that the collar is in full 360 degrees contact against the surface of the item being lifted. Use shim sheaves, if necessary, to obtain the correct orientation of the eye. Use a 2-legged sling if lifting with a pair of eye bolts. Never use a sling in a basket format. As an eye bolt, hoist rings are an excellent alternative to eye bolts. Their biggest advantage is their flexibility. They can be turned in all directions, both horizontally and vertically, without being derated. Always ensure the bushing flange is in full 360-degree contact with the surface of the item being lifted.
So there are actually 3 types of eye bolt. The dynamo, which don't have a collar, and then you have this collar eye bolt, and those collar eye bolt with a sling, with a link. These are the 3 types of eye bolt. So you can see this lifting of this piston and cylinder head, cylinder cover and all this. You have the eye bolt that is threaded, a threaded hole inside this cylinder cover and all this. Then you have to screw on the eye bolt into the cylinder cover. And also this, you have this lifting, so-called these special tools. Actually is for lifting the piston, where you have this, like a spreader, then you can actually lift up this piston using this spreader here. It's specially made by the maker of the engine manufacturer. So very important is to use this eye bolt that is have a collar. Those without the collar, you only can do vertical leaf, because you cannot use it to at an angle. You will break the eye bolt. So with the collar, you can use it at an angle, but not exceeding 15 degrees, And the best is this threaded part, the threaded hole. It's supposed to be the threaded is deeper than this threaded part of your eye bolt, because you have to make sure that the collar actually sits well onto the surface of this load. If not, then you can use, let's say if your hole is a bit too shallow, the threaded hole is too shallow, you can either use a shim or washer to make sure that the collar is sitting well seated onto the load. Yeah. Make sure that you have the collar and the thread are in good condition as well. You make sure that the thread are not broken or worn out. Once you have the worn out threads and broken threads, don't use it. And before you screw down the bolt, the eye bolt and all this, make sure that you have clean up all the thread, and use the sling. Make sure the sling is of adequate length, because as you see from the video clips, you are not supposed to lift anything. The sling angle is not supposed to be exceeded 45 degrees. Yeah, because the stress on the sling will increases as the angle decreases. Yeah, here is another video clips on proper use of this. The best, actually, the most expensive is to use the hoist ring, as just now we see the video clips where you have the hoist ring where you can actually swivel 360 degree, and also you can pivot at 180 degrees. So if you use this eye bolt, make sure that the load, the sling actually is not more than 15 degrees. If it's more, you will result in the eye bolt will be bent, applying a correct angle, the load angle. So maybe you can watch this video again, and this is also talking about the eye bolt.
Crosby's HR-125 swivel hoist ring is the premier component for connecting rigging to the load. The swivel hoist ring provides 100% of rated capacity at any horizontal angle of loading when properly installed. This performance is achieved because it swivels 360 degrees and pivots 180 degrees. You're assured of Crosby quality by the information stamped onto each swivel hoist ring. Included is the company name or logo. Also, the product identification code, or PIC, used for material traceability, is located on each load-bearing component. It's important to note that all load-bearing components of our swivel hoist rings are heat-treated, utilizing Crosby's perfected quench and tempering process. The product is available in both UNC and metric threads. UNC threads are available in working load limit capacities from 800 pounds to 30,000 pounds with a design factor of 5:1. Metric threads come in working load limit capacities from 400 kilograms to 16,900 kilograms and have dual design load factors of 4:1 and 5:1. In addition, all swivel hoist rings are furnished individually proof tested to 2 1/2 times the working load limit with certification. The product is also fatigue rated to 20,000 cycles at 1 1/2 times the working load limit. And finally, each product comes individually packaged with application instructions and warning information. UNC thread bolts are grade 8 alloy socket head cap screws designed to ASTM A574. Threads are UNC 3A. Metric bolts are grade 12.9 alloy socket head cap screws designed to DIN 912. Threads meet ASME ANSI B18.3.1M standards for metric threads. The bolt on the swivel is secured by an E-clip, which allows for easy disassembly and assembly necessary for periodic inspections. Calculating load limits with the S279 machinery eye-bolt is straightforward. Using 2 slings in a true inline load, each side will see half the total weight. From the Crosby lifting guide, notice that for a 90-degree horizontal sling angle, the load angle factor is 1. In this example, the total load is 5,000 pounds, which is divided by 2 for each sling leg, and then multiplying by the load factor, which is 1. The result is that each side lifts 2,500 pounds. To select the proper bolt, refer to the Crosby lifting guide. Note that the panel does not mention the S279 because the information is the same for all Crosby shoulder eye bolts. We need to select an eye bolt whose working load limit exceeds the required load of 2,500 pounds, which in this case is a 1/2 inch machinery eye bolt with an inline working load limit of 2,600 pounds. Let's now look at how increasing the horizontal angle affects the size fitting required. For 60 degrees, the load angle factor is 1.155. Again, we divide the load of 5,000 pounds by 2 and then multiply by the load factor to determine the load each sling leg will see. In this case, each sling is loaded to 2,887.5 pounds. We will round the calculated load to 2,888 pounds. Referring to the lifting guide, you will notice 4 columns showing the rated capacity of Crosby shoulder eye bolts at various horizontal angles. Crosby shoulder eye bolts have a catalog rating based on inline loading. As side loading occurs on the eye bolts, they must be down-rated. The smaller the horizontal angle, the greater the reduction in the working load limit. As an example, let's look at the 1/4 inch size. At 90 degrees or inline, the rating is 650 pounds. As the horizontal angle changes, so does the resulting working load limit of the eye bolt. At 60 degrees, the rating is 420 pounds. At 45 degrees, the rating is 195 pounds. And at horizontal angles less than 45 degrees, the working load limit has been reduced to 160 pounds. For additional information or videos about the many products and services offered by the Crosby Group, you may contact Crosby direct.
So you can see this a well-known eye bolt is actually the expensive Crosby product. They are very, very expensive, but they are very good quality eye bolt. So as a rule of thumb, you should not be using exceeding 45 degrees. But if you want to use less than 45 degrees, you can still use it, but make sure that you must derate it until according to the manufacturer of the eye bolt recommendation. So orientate the eye bolt in line with the sling. Orientate it so that it's in line with the sling. If the load is applied sideways, the eye bolt may bend. So if you twist it around this way, and then the eye bolt may bend. So you must actually align it to be in line with the sling. Yeah. So this is to prevent the eye bolt from bending. Then pack washer between the shoulder and the load surface to ensure that the eye bolt are firmly secured, contact with the surface. Make sure the nut is properly torqued. In some cases where there is a nut that is going through the load, some of this steel plate or maybe object that you're going to lift is thin but it's heavy, and you have this nut going through the object, that the load to be used, you can use a nut, properly tighten the nut and torque it. Engage at least 90% of the thread in the receiving hole when using shim and washer. So in case you have to use the shim to make sure that the collar is in contact with the surface, but you also have to know that at least 90% of the thread length is actually inside the receiving hole. Yeah, if not, if it's too short, then the thread may not able to hold the weight of the load. You know, it may just shear off all the thread. Attach one sling leg to each eye bolt. Yeah, you cannot use the eye bolt and then we have two sling there. It's not the correct procedure. Inspect, clean the eye bolt and the hole. Check for bend and cracks on the worn thread. You know, screw the eye bolt way down and properly seated onto the surface. Ensure tap holes on the screw bolt and the screw eye bolt has a minimum depth of at least 1.5 times of the diameter. Yeah, the track dam, the length and all this must have at least 1.5 times of the bolt diameter. Install the shoulders at the right angle to the axis of the hole, and shoulders should be full contact with the surface of the object. Use a spreader bar with regular eye bolt, those non-shoulder eye bolt, to keep the angle, the lift angle 90 degrees to the horizontal. So if you are using this eye bolt without shoulder, you only can lift at 90 degrees. That means you can't use the angle lift. You can't do angle lift. So you have to use this spreader to attach to the sling and eye bolt. Use the eye bolt at horizontal angle greater than 45. Sling strength at 45 degrees is 70% of the capacity eye bolt. Yeah, just now the factors that they use for calculating all the angle of the sling and the lifting capacity is reduced because of the angle of the sling is getting smaller and smaller. So best advice is not to use it exceeding less than 45 degrees angle sling. Yeah, use a swivel hoist ring for angle lift, you know, because they can be pivot at 180 degrees and it can rotate 360 degrees. Okay, let's do a small exercise on the lifting of the piston and cylinder head using the eye bolt. I should check and ensure two things. What are the two things? I put there more than two things are minimum. So ensure eye bolts have a collar, yeah, and the threads are in good condition, and both eye bolt are screwed way down hard onto the collar that touches the cylinder head or the piston. So if there is a spreader bar to be used, make sure you use a spreader bar for the piston, especially the piston. Normally the manufacturer has the spreader bar. If not, then make sure you clean up the hole. The receiving hole is properly cleaned up before you screw down the eye bolt and all this. There's a lot of things to be checked when you're using the eye bolt, because that is actually the weakest part when you're doing this lifting operation. The eye bolt itself is the weakest part. Yeah, if you use the one thread, you'll just give way. The thread will just give way. So eye bolt is very important. Okay, now we there's this danger of doing manual lifting. It's just that you're carrying heavy loads and all this. You have to be very careful about, using manual carrying of loads and all these heavy loads and all this, because if you don't take care, you may hurt your back and all this. Your spinal may be sprained and all this. So it's important that you must lift up the load in a proper way. So like this guy in the picture, what actually went wrong, how come is slip and fall while carrying this load, So anyone can say, give a reason. There's actually exercise here. Let's give 3 reasons why the person above sketch is slipping down with the box. So you can observe that the floor is slippery, and then you can see he's not wearing proper boots. It's just like those fashion boots. And also the view is obscured. He probably can't see where is he going. And he can't even see whether the floor is slippery or any obstruction has been blind by his the box. So very important is you must have a clear vision of your field of vision must be clear. Make sure that the path that you are going to walk, there's no obstruction and it's not slippery and all this, and proper footwear and all this. So let you see a video on how to do safe manual lifting. Let's sit back and watch this manual lifting video.
Grammarly does more than catch errors. With Grammarly, you can find really good.
Hello, I'm Ernie Medina, Senior Safety Consultant with FFEA Mutual. This short video features safe lifting tips and techniques to reduce back injuries. Underestimating the weight of an object and incorrect lifting techniques are one of the top 2 causes of back pain and injury. Back injuries are expensive to treat, often subject to re-injury, and can be career impacting. So always plan ahead, know your limits, and think before you lift. One of every 5 workplace injuries is back related. It's the second leading cause of lost time after the common cold. When lifting objects, be sure to keep your back in mind. Back alignment and support, avoid twisting, close to the waist, keep movements smooth. We recommend practicing and using the following safe lifting techniques. Single weightlifter technique. For good balance, spread your legs shoulder width apart. Squat by bending the knees and hips with your heels down. Keep the load close to your body with the heaviest side closest to you. Keep the chin up. Engage your ab muscles and rise up with your legs in a slow and smooth motion. Do not jerk or snatch the load. Diagonal lift technique. Check your posture. Place feet shoulder width apart, 1 foot forward and feet in a diagonal position. Rise up with your legs and hug the weight close. Do not twist your body while lifting an object. Team lifting. Communication is important when lifting an object with someone else, so choose your partner wisely. Develop a game plan before lifting and unloading. Know exactly where you're going and the direction you will take. Make sure there is a clear path and watch for tight doorways and corners. If the load is too heavy, let your partner know. Carrying the load. Make sure you can see where you're going. Hold the load close to reduce lower back strain and take small, stable steps. Unloading. Squat down with the load, being careful not to bend your back. Keep your chin up and be careful of fingers as you unload the weight. Reaching overhead. Use a two-handed tilt to test the weight before moving from the shelf. Slide the load towards you and hold the load close to your body as you bring it down. Remember not to store heavy items too high. Avoid lifting heavy loads above your waist and make sure you can see where you're going. Here's an easy tilt test for overhead objects. Use a pencil if you're unable to test the weight of an object using a two-handed tilt. If you can't move the box with your pencil, it's too heavy to be stored overhead. For more workplace safety tips, visit the safety tab on our website or contact your safety consultant. Thanks for watching and staying safe at work with FFEA Mutual.
So this is a very useful video, especially when you are doing this manual lifting, carrying heavy objects and all this. You don't want to injure your spinal, and then your back injury is very difficult to treat. It could be some of them, it could be ruin your career. If you have injury that injured your spinal, you could be paralyzed. It's very dangerous. So make sure you do a proper safe lifting of loads. The next one is very commonly happen. Slip, trip, and fall, which is most commonly in the workplace, even in office space. Also, in working in office, there's a lot of trip and fall cases happening. So just watch these video clips on this slip, trips, and fall.
Have a nice trip. See you next fall. I'm sure you've heard this common joke, and we've all had a giggle in comedic films when characters slip and trip. Though funny in movies, slips and trips and falls at work are no laughing matter. In the workplace, these accidents have caused over 200,000 serious injuries and 345 deaths in 2016 alone. You don't have to become a statistic. Many, possibly even most, slips, trips, and falls can be prevented. In this course, we'll learn more about what can be done to help you stay on your feet and stay safe. Now, before we get to the how-tos, let's take a moment to define some terms. What exactly is a slip, a trip, and a fall? A slip occurs when there is too little friction between a person's foot and the walking surface. Slips are often caused by spills, water, grease, dust, wood shavings, leaves, pine needles, and other debris that can make floors slippery. Highly polished or freshly waxed floors are also slip hazards. A trip is when a person's foot or lower leg hits an object and the rest of their body keeps moving. Trips are most often caused by clutter in aisles or walkways, extension cords, hoses, open filing cabinets, boxes. All of these are trip hazards. Trips can also be caused by uneven floor surfaces, unexpected drops, and gaps or cracks in walking surfaces. Both slips and trips result in lost balance. Lost balance often leads to falls. Falls to the same level, such as slipping on wet leaves and hitting the ground, can and do cause injury. But a fall from a greater height, such as off a ladder, down a flight of stairs, or from a platform, is even more dangerous. Injuries from slips, trips, and falls range from minor to the very serious. Sprains, strains, bruises, broken bones, cuts, and head injuries are all common. The good news is slips, trips, and falls and the injuries they cause are avoidable. What can be done to prevent them? First of all, some of the responsibility rests with your employer. OSHA has a number of rules and regulations pertaining to slip, trip, and fall hazards. For example, your employer is required to regularly inspect your workplace and address any issues they find. This might include providing fall protection like guardrails, harnesses, or safety nets. It might include making sure there is an anti-slip edge to all stairs. It definitely includes providing adequate lighting in all work areas and walkways. There are many ways your employer can make your workplace less prone to slips, trips, and falls, and they're all regulated by OSHA. Your employer is also required to provide you with training on the hazards in your workplace, how to use and maintain personal protective equipment, and best practices for working and walking safely. It's not all up to your employer, however. You have responsibilities too. Let's explore the top ways you can avoid slips, trips, and falls at work. Wear the right PPE. For many people, this just means wearing non-slip shoes. Depending on your job, however, there could be other equipment for you to wear. Proper use and maintenance of PPE is a must. Carrying too many items at once, looking at your phone, leaving sunglasses on when you come inside, and being distracted are risky behaviors that we're probably all guilty of on occasion. Being aware of your surroundings and maintaining visibility ensures you don't trip over an object that you couldn't see or didn't notice. Don't run at work. Take careful steps and be especially cautious on wet, icy, and highly polished flooring surfaces. When you lengthen your stride to run, you automatically increase your risk of slipping and losing your balance. Be extra careful on stairs. Use the handrail and watch out for slippery or uneven surfaces. Maintain a neat and tidy work area. Boxes blocking the hallway, loose papers strewn across the floor, extension cords zigzagging back and forth, open filing cabinets, and other clutter increase the risks of slips and trips needlessly. Show respect for your coworkers by keeping walkways clear at all times. This doesn't apply to everyone, but if you use a ladder at work, you must know how to do so safely. Before using a ladder, make sure it's in good condition. Do not use a ladder with cracks, warping, or other defects. Make sure the ladder is stable before you begin climbing. Use both hands to climb the ladder, and always maintain a solid center of balance. It only takes a second for an accident to happen. One careless moment, one bad decision, or one ill-timed distraction could put your health at risk. Slips, trips, and falls can happen anywhere. Don't take your health for granted. Keep these best practices in mind to stay on your feet and stay on the job.
So you've seen this video clips on slip, trips, and fall. I'm sure many of us have experienced before one way or another, you know, because it's very common accident or incident happen. You know. So be careful as in your workplace, especially in marine field and offshore shipyard and all this. And for my case, I have experienced, especially in the doing survey in the tank, you know, in the oil tank. This is, I mean, myself, I have falls many times, you know, but sometimes it's just happened that it's out of your control, you know. For example, I was once doing a survey on an oil tank, this VLCC tank, you know, the cargo oil tank is so huge, and it's basically impossible to light up the whole big tank. That is really impossible to light up. Even you still have to carry a torch to do your inspections. And so, you know, the cargo tank, where there's a suction box that is a recess in the cargo tank where you suck up all the crude oil and all this, you know. And then where the bear mouth is. Yeah, it's very, very big tank that is recessed into this double bottom, you know. So, and it's covered with all this crude oil, and it's like black, you know, black color. So when you walk and all this, you are not careful. I have ever stepped one leg into the recess box, into the tank, and the whole boiler chute is coated with all the oil starch, you know, sludge. Yeah, but luckily it did not injure my body, you know. So sometimes it's even if you are so careful with a torchlight and all this, you still cannot avoid incident happen. So, and also be careful of all the manhole, you know, this ballast tank and all this. You have so many tier in your ballast tank, and then this seawater. After you pump out all the seawater, the surface of the tank top and all this are very, very slippery, you know. You can easily slip and then fall through the manhole, you know, and get a broken ribs and all this, you know. So just be careful of all this hazard. That's why I was telling hazard is everywhere. You know? Sometimes it's really unavoidable, but you have to reduce it to as low as possible, the risk of it happening. Okay, we talk about this course note that you have. There's one topic on boiler safety, and I was actually quite puzzled. Why did they want to touch on this boiler? Because most of the most of the hovercraft and small boat and all this,
no boiler.
yeah, doesn't even have a boiler, and even so, but because it's there, Then maybe we just talk something about boiler and all this boiler safety lah. Because for me to touch on the boiler is actually quite very dangerous. It's one of the most dangerous to work with boiler. Not only for operation, but as well as doing a survey and inspection of boiler is also very dangerous. Yeah. So maybe just go through on some of the boiler. But before we start to talk about the boiler safety and all this, maybe I have to let you know about the type of boiler and all this, because there are quite many types of boiler. So the most even the shower, the heater that you use in your home for a shower and all this, it's actually a small boiler. So it's a small little boiler inside. So what we will see is these are all the commercial boiler, which is mainly for the ships. In fact, nowadays you don't find any main boiler. What is on board this merchant ships and all this, these are all called auxiliary boiler. They are not called the main boiler, because the term main boiler is actually for steamships, where they use the steam to drive the turbine, to drive the propeller. Then that boiler is called a main boiler. It's very, very huge. And those that is on merchant ship nowadays, because there are not many main boiler. The only main boiler which I come across for nowadays this vessel, merchant vessel, is the LNG vessel, because the why the LNG, those big LNG vessel, they are still using steam to drive the propeller, the turbine, and then the steam turbine, and the propeller. It's because the cargo itself is LNG, is liquefied gas, natural gas, and this liquefied natural gas is actually compressed and keep it in a very low temperature, liquefied the gas, and then once it liquefied, you have to maintain it to minus 296 degrees. It's very, very cold. It's once this liquefied gas comes out through the pipes, if the pipes are not well insulated, immediately you can see all the ice start forming on the outside of the pipes. It's very, very low temperature. It's in the range of called the cryogenic temperature, where they use it in the space technology, cryogenic, where the temperature below zero. Like airplane and all this, it's only about minus 40 outside when you're traveling on the plane and all this. And this LNG gas vessel, they have this called the boil-off gas. So this boil-off gas is actually tapped from the cargo tank, and goes into the main boiler to use it to heat up the steam boiler. I mean the boiler itself to create the steam to drive the turbine. So instead of using fuel to using fuel for the boiler, the main boiler, they are using the boil off gas. So it's actually very economy because instead of wasting all this boil off gas, you use it to in the main boiler to create the steam for the propulsion. So auxiliary boiler that you've seen on all these vessels, the oil tank, all these oil cargo vessels, crude oil vessels, they are mainly used for heating purpose, like thermal oil heaters and all this. Also the what you call the
heavy oil.
Yeah, heavy oil. You need all this heating for using steam for heating or thermal oil for heating. You know, so these are auxiliary boiler that creates the steam for heating purpose. So boiler is a pressure vessel, you know, which is the water is evaporated, generated the steam, and also generated steam is accumulated. There's actually two types of boiler. There is water tube and fire tube. So the picture here is actually the water tube. Water tube means that the water is in the tube, the fire is outside the tube. Then you have the fire tube is where the fire is in the tube and the water is outside the tube. That's why there's these two main types. So the steam that is coming out from this boiler, the drum, the steam drum, this is called the top one is the steam drum, and the bottom one is, we call it the water drum, where you feed water in, and then the boiler, the fuel, the burner will burn the tubes, and then you will, when the water is heated up, you will actually rise, you know, all this water will rise up, and then you will become generated this steam that is called saturated steam. Saturated steam is actually, we can call it like wet steam. So because wet steam, you don't use it wet steam for heating into the heating coil, because wet steam, there's a lot of what you call water, you know, wet steam. So the wet steam is actually gone through heating again with this superheater. So the wet steam actually saturated steam goes through this superheater, and the steam is further heat by this burner here to create superheated steam. And superheated steam is very dry, and its temperature is also not 100 degrees. It's more than 100 degrees. It's very, very hot. So, and features of all this, the safety features of all this safety for boilers are quite common and typical. You see, this is where the fire tube is. This fire tube is where the burner is here, and the burner actually goes through this flue gas pipes. Flue gas pipe is actually the fire tubes. So the water is actually outside of the fire tubes, and then it will heat up the water here, And this is the steam space where the steam is being generated and distributed out. Then you have the furnace where your burner is here, and your blower is also here. There's a big blower fan here. Yeah. So here you can see the types between a water tube and a fire tubes. Yeah. Water tube is where the water is in the tubes and the furnace or the burner is outside. And then you have this stack here, the hot gas coming out and the steam coming out from here. And the fire tube is actually the fire is in the tube and the water is outside. So this case, this is a very old horizontal typical boiler, yeah, which is actually fire tubes, where here is your burner, the 3 burner, and then the flue gas will go through all these small little pipes, and the water is outside these pipes. And then the shell of the boiler is a big cylinder, and we used to call this a donkey boiler. I don't know how it comes to this called donkey boiler, where it's very difficult to do inspection. You can't get inside the boiler unless it's big enough. You can go in through this. There's a manhole here. I think this is a manhole here, where you can get into the water space here. That's the most you can do. And for the fire side, you basically difficult to inspect whether there's any cracks in the tubes and all this, because it's limited space. Even though if you get into here, you can't see much also, because all these fire tubes are basically very closely knitted. So the anything that is mounted onto a boiler, we call it mounting. It's what I call boiler mounting. The steam stop valve, the safety valve, and all this blow down valve and all this. These are also called mounting. Water gauge, water level gauge, the feed valve, and all this. These are all mounting on the boiler. Yeah. So can you tell me what are the most important fittings that in the steam boiler? Just now the here, all this mounting here, you have the safety valve, the stop valve, the steam stop valve, and then the water gauge, yeah, and the pressure gauge, yeah, and then you have the scum valve, you know, this blow down the scum. So anyone want to give it a go to name the 3 most important fittings or mounting?
Safety valve.
I think, yeah, one of them must be the safety valve, the most important. Yeah. What about the next one? The next important valve that you find?
Stop valve.
Which one?
Stop valve.
Stop valve, not really, because if you close the stop valve, it can be even more dangerous because the steam pressure will build up. So stop valve, yeah, must valve? Always.
Air push valve.
Which valve?
The air push valve.
Air push.
Yeah.
Air push is normally
before you fill up. Right?
Not really that really important. It's just to purge the air that is you know, in the steam space.
Yeah.
The main feed valve?
Main feed valve is important, but normally we have two feed pump. Yeah, if one feed pump fail, the other feed pump will automatically cuts in. You know? So it's important, but for operation to monitor the boiler safety, actually is the water level and the pressure gauge is the most important. Yeah, because if you have a steam salt valve fail and all this water cannot go in, then you have water level low, so there will be alarm. So when you do operation, if you find that the water level coming low, that means your steam main feed valve is not working or your pump is not working. Yeah, then the water level will have an alarm when it lowers to a condition where it's low, you will shut down the boiler. Yeah, you will shut down the boiler. So the next thing is the pressure gauge, which is also very important. Yeah, because if you do not have the pressure gauge and your steam is your fire is not controlled, your burner not controlled, it keep on firing and firing and firing until the steam pressure becomes built up too high. Of course, if it's exceeded the safety valve limit, the setting, then you will leave up the safety valve. So before you leave up the safety valve, your pressure gauge will have monitoring the pressure to shut down the boiler instead of waiting for the safety valve to be lifted. So pressure gauge is very important. So pressure gauge is one thing that they have always has mechanical gauges, and also there is this remote gauging that is remote gauging will be going through your alarm system to set your limit for steam pressure. If exceeding the setting, you'll give you an alarm that is high pressure, you know, you got to shut down the boiler. So these are the three fittings that is the most important to a boiler: water level, pressure gauge, and the safety valve. Very, very important. The rest of it is important, but it's not as most important as these three items. Yeah, these three items is one of the most important. That's why when you go to engine room control, you have all the remote gauges and all this. You will definitely find the boiler. We have the water gauge, you know, and then the pressure gauge. And then, of course, the safety valve, you need to do some testing. They have this lifting gear to test your safety valve, whether your safety valve is in working condition. Yeah. So maybe it's time that we stop this boiler. Next, after the break, we will continue with this all the safety aspect of the boiler. Because I think we all need a break for the coffee break or whatever. So go for your coffee break or smoke break or tea break or whatever. And I will see you at 3:30. 3:30, yeah? Okay. Yeah, enjoy your break.
Okay.
Bye.
So how many guys going for this swab test?
I'm going on Wednesday morning.
You're going on Wednesday. Cool, cool.
Yeah.
Is
Friday.
or Friday. Tomorrow. What time is it tomorrow? 10:45. Okay. So do you all go to the regional testing center or what? Where is testing is?
My place is at somewhere Jurong East.
Or Jurong East there.
School, whole school.
Hmm. Okay.
Yeah, mine at Kaki Bukit, one of the primary school.
Or the former primary school there.
Yeah.
Oh, okay. Because for mine, I went to it's Singapore Science Center, the former Singapore Science Center there. It's all, I think it's all for the MPA stuff. MPA. Yours is it under MPA or what?
EDB.
Or EDB, under EB. Or what, ESG and all this. But for MPA one is the routine one is like every 7 days, right?
Mine also 7 days.
Or every 7 days.
Yeah.
Because I'm entering the yard. Yard
Yeah.
requirement is 7 days.
Then and the third and fourth day you must
ART.
do your art test, right?
Yes.
ART, yeah. I think it's the same. It's all the marine requirement.
Yeah.
MPA requirement. Okay. If you are going for tomorrow 10:45, right? Yeah. Then you can go ahead with your swab test. Then but morning we will take a shot. Yeah. Then you should be back after lunch, right? After lunch, yeah. So after lunch we take another shot. Then close of the day we take another shot. Yeah. So at least you have your time is all locked into the Zoom. Yeah. You lock in and lock out. Yeah. Okay, we shall continue with the boiler. The three most important fittings that we will touch on that. The first one is the safety valve. The boiler safety valve is also in the SOLAS requirement. Every steam boiler should provide at least 2 safety valves. Yeah. This safety valve is actually to lift up the you blow up, when limit has been set. Normally we set to about 3% of the working pressure. Yeah. So then main features of the safety valve is the most usually the most popular type of safety valve that you use for boiler is the improved high lift. You see some of this is safety valve that is not the high lift type. They don't usually use for steam boiler because the high lift is the reason why they call it high lift is that when the mechanism itself, once it reaches the set pressure, the valve will lift up quite high, and you will let go to release the pressure for a period of time, until the pressure is way below the set point, much way below the set point. Then it starts to close. because if you don't have this high lift type of safety valve, you can call it like we call it like flooding. Flooding, where the safety valve was designed such that it open and close because it doesn't release a longer time, and then the pressure will start to build up, then it release a bit, then it close again. It causes the flooding of the valve seat. It's very damaging.
Yep.
It's very damaging for the valve disc and the seats, you see. So this high lift safety valve is, once it lifted up, it continue to in a position such that the pressure release is actually way below the set point before it start to close. So we will see video clips on all this the safety valve. Just watch this video.
Your supervisor will probably recommend that you replace the part. If the steam cutting is relevant, you'll remove in the course of disassembly, handle these parts carefully and set them aside where you can clean the valve and gotten together the tools you need. You're ready to begin disassembly. Disassembly starts at the top of the valve with the removal of the hand lifting assembly. The first part to be removed is the pivot pin, which is usually locked in place with a cotter pin. As with all the other parts you'll remove in the course of disassembly, handle these parts carefully and set them aside where you can find them later on. Once the pivot pin is out of the way, the lifting lever can be removed. Next comes the cap. The cap protects the top of the spindle, the lifting nut and its lock nut, and the compression screw. It's usually held in place by a set screw. At the top of the spindle is a lock nut and the lifting nut. Use a pair of wrenches to break them free. Then, turn them off the spindle and set them aside. The lock nut holding the compression screw in place should be broken free next. Again, use a pair of wrenches, but be certain that the wrenches you use are matched to these parts. Otherwise, you could round off the flats of the screw and its lock nut. It's not necessary to remove the lock nut from the compression screw. Just back it away from the yoke. Remember that the compression screw is precisely adjusted to maintain exactly the right amount of tension on the valve spring. So that you can return it to its original place when you reassemble the valve, you have to keep a record of its position. One way to do this is to make two small witness marks, one on the top of the yoke and the other on the flat surface of the screw itself. By setting a divider so that one tip is in each witness mark, the distance between the tips of the divider becomes your record of the distance between the witness marks. When using this method, it's extremely important to put the divider where its setting won't be changed, either by its falling on the floor or being picked up by another mechanic. To prevent any possible error when installing the compression screw later on, always make a second record of its original position. The easiest way to do this is to count the number of turns it takes to disengage the compression screw from the threads in the yoke. Using the witness marks as a guide, count each time the screw completes a turn. When the compression screw is loose enough, you can turn it by hand. But continue counting. Each time the witness marks pass each other, count another full turn. Stop counting only when you feel the threads disengage. Then lift the compression screw off the top of the spindle and set it aside. Immediately write down the number of turns it took to free the screw. Don't rely on your memory. Next, break the yoke nuts free and remove them from their studs. When the last nut has been removed, lift the yoke off the valve body. Be careful not to bang the yoke against the studs or the spindle, and set the yoke aside where it's safely out of the way. At this point, it's a good idea to set up a pair of V-blocks so you have a safe place to put the spindle when you remove it. Remove the spindle and the feather by lifting straight up to avoid banging the feather against the sides of the casing. A feather that's even slightly damaged will not function properly. Separate the spindle and the feather. Then set the spindle on the V-blocks and place the feather on the table's seating surface up so it's not damaged by contact with the table. Looking straight down through the top of the valve body, you can see that the upper adjusting ring and the lower adjusting ring are exposed. Because their position is critical to the function of the valve, measurements must be taken before they're removed. The exact position of the upper ring is measured first. This graphic will give you a clearer picture of how this first measurement is taken. A rigid rule is laid across the lip of the valve body. Then a second rule is placed vertically with its end flat against the top of the upper ring. The measurement is taken on the vertical rule at the point where it intersects with the horizontal rule. Using this method, you get an accurate measurement of the distance between the top of the upper ring and the lip of the valve body. When you get an accurate reading on the vertical rule, write the measurement down. As the mechanic's notes show, the distance between the top of the upper ring and the lip of the valve body is 5/8 of an inch. After recording this first measurement, remove the upper adjusting ring. This is done by first cutting and removing the locking wire that holds the upper ring and lower ring locking pins in place. The upper locking pin is then broken free. And removed from the valve body. This frees the upper adjusting ring, which is removed by simply unscrewing it until it comes free. Check the ring for any obvious signs of wear or damage. Then set it aside where it won't fall on the floor or get banged around. The next step is to record the position of the lower adjusting ring. Here, the mechanic is using a lapping block, but a rigid rule will work just as well as long as it's perfectly straight. He lays the lapping block flat on the valve seat. Then he breaks the lower adjusting ring locking pin free. And removes it from the valve body. This frees the lower ring so that it can be turned. Next, the mechanic uses a screwdriver to reach into the valve body through the lower locking pinhole. Looking through the top of the valve, we can see that he's using the screwdriver to turn the lower ring. He carefully counts the number of notches that move past the pinhole as the ring turns. When the lower ring touches the lapping block, he stops. He immediately writes down the number of notches that he counted, in this case, 10. This gives him the information he needs for reinstalling the lower ring in its original position later on. He then removes the lapping block and turns the lower ring until it disengages from the threads in the valve body. He removes the ring, briefly inspects it for obvious signs of wear or damage, and sets it aside. All that remains now is to remove the spring and the spring washers from the yoke. This is done very simply by tilting the top of the spring outward. A quick inspection will tell you whether or not these parts are in good condition. The spring and the washers are a match set. This one is brand new and its parts are clean. When you're doing safety valve maintenance, the step after disassembly will be cleaning all the parts thoroughly. This can be done at a cleaning station using solvent and a brush, or it can be done by dipping each part directly into solvent. In either case, be certain to use a solvent recommended by the manufacturer and get all the parts as clean as possible. Clean parts are easier to inspect and they fit together better when you reassemble them. After cleaning, inspect each part carefully. The 4 parts that deserve the most careful inspection are the feather, the seat, the adjusting rings, and the spindle. Let's consider each one in turn, identifying some common types of damage you're likely to see, and discussing what to do when you find a part that's worn or damaged. We'll start with the feather. When inspecting the feather, the first thing to look for is cracking. Even the smallest cracks are serious, and a cracked feather must be replaced with a new one. Steam cutting is another common problem with feathers. If the damage is this bad, your supervisor will probably recommend that you replace the part. If the steam cutting is relatively minor, you can usually restore the damaged surfaces by lapping them. Because this feather is flat, it can be lapped on a lapping plate. A layer of lapping compound on the plate provides the abrasive required to restore the surface of the feather. If the damaged feather is round or cone-shaped, it can't be lapped the way a flat feather is. Your text gives information on how to repair feathers of various shapes. Another part of the valve that's subject to cracking and steam cutting is the seat. As we saw during disassembly, the seat in this safety valve is a permanent part of the valve body. If it were damaged as seriously as the one you see here, you'd have 2 choices. You could use a special tool specifically designed to restore the damaged surface, or you could mount the valve in a lathe and remachine the seat. Both procedures are discussed in your text. If the seat has only minor damage, lapping is the best solution. Lapping a seat requires special care. So let's take a few minutes to watch the mechanic demonstrate the proper procedure. Just keep in mind that the seat in this valve is flat and a part of the valve body. The procedures for lapping other types of seats can be found in your text. To begin, he needs a lapping block and 1 or more types of lapping compound. Because the valve is new and this is only a demonstration, he'll use a very fine lapping compound. If the seat were actually steam cut or nicked, he would use more than 1 type of lapping compound. He'd begin with a coarse compound to quickly remove most of the damaged metal. Then he'd use progressively finer compounds to ensure a flat surface. He begins by putting a few dabs of compound on the face of the block. Then he places the block on the seat and begins lapping. The abrasive compound between the block and the seat wears down the surface of the seat so that it conforms to the perfectly flat surface of the block. It's not necessary to exert any downward pressure on the block, but it is necessary to move the block in a smooth, regular motion. As you can see here, the mechanic alternates between a figure-8 motion and a circular motion. When he feels that he's achieved a smooth, flat surface, he removes the lapping block and cleans the compound off of it. He then uses solvent to rinse the compound off the seat and other internal surfaces of the valve. He wipes away all remaining residue with a clean cloth. A flashlight helps him to inspect the seat for any nicks or uneven spots. If his inspection showed any irregularities, he'd have to continue lapping until they disappeared completely. Now, there's one thing to keep in mind, regardless of what type of seat you're lapping. Because the lapping process removes metal from the seat, it's likely to change the set points of the valve. So, when you reassemble the valve, you'll probably have to compensate for this change by adjusting the compression screw and the adjusting rings. Again, you'll find more information about this in your text. Okay, that covers inspection and certain types of maintenance of the feather in the seat. Now, what about the adjusting rings and the spindle? Well, the adjusting rings are subject to nicks, cracks, and steam cutting just as feathers.
This video clip is actually quite long, but we don't need to cover all this. These are specialized maintenance job that the crew doesn't do this maintenance of this safety valve. Normally, they will send it out to the maker or the experts in all this overhauling of safety valve. Normally, this job is done outside, not by the crew, because lapping of this safety valve and all this adjustment of the safety valve is actually a very precise job, which normally the crew won't do it. The expert will do it. So next, we go on to the pressure gauge, the main steam outlet. Main steam valve is actually to shut off valve when it close, isolate the boiler from the main stream. Check valve is mounted on the main stream to prevent the steam from backflow into. So the main steam valve is always a check valve there to prevent the steam going back to the boiler. So this is one of the features of the main outlet valve, steam outlet valve. Okay, next is the pressure gauge. There's always two pressure gauge on the boiler. One is on 9, taken from the steam drum to the control room to display the steam pressure remotely. This one, remote steam display, is also use it for alarm setting and all this, you know, for this boiler pressure. The other one is actually mounted directly onto the boiler steam drum. So that one is on the boiler itself. This is the mechanical one, where they call it the most what you call reliable, because it's all mechanical, and it's called the Borden tube type of pressure gauge. So the one that is remote can be used for incorporating a cut-in and cut-out automation system, like inner pressure, to use to operate the boiler burner. You know, if the steam is pressure is too high, and then you need to cut off and shut down the boiler, so they use this incorporate the steam, the pressure gauge, to shut off the burner, so that pressure will not reach to a safety valve set up. I mean, the blow up pressure. See, when pressure reaches a set value, the boiler will stop firing. So when the pressure drops below a set value, the burner will switch on automatically to raise the steam pressure. And the other is the water level gauges, which is also one of the most important fittings that we find in the boiler. There's two local water gauges connected to the front of the boiler. Each gauge has been provided with the shut-off valve and a drain valve. And the shut-off valve fitted on top and bottom of the side glass have a quick closing mechanism to be used in case of broken glass. So this is a safety features that is built on the level gauges. In case there is a broken gauges and you have a quick closing mechanism that prevent all this steam from coming out from the broken gauge. You know, pipes for the drain cocks and the level gauge must be led to open drain visible for inspection. Conservation Society demand that this should be fitted to reduce the damage in loss of water in the boiler due to burst tube and failure of the feed system. Yeah, if the feed supply is failed, then there's no water in the boiler, then all the tubes will get burned, or will damage the tubes. So then you have to replace the water tubes, or you replace the smoke tube or the fire tubes. So these are costly. To replace these tubes is costly. So main cost if the boiler furnace is the blowback. It's like a flashback. This is the why, I mean, many years ago, I think in Shell in Bokum Island, the Shell have replaced a new boiler. And I can't remember, it was quite a long time ago, where the refinery Shell in Bokum, there is one or two engineers got killed because of the boiler explosion. So this boiler explosion actually happened is because the furnace space is full of this hydrocarbon vapor, which means the oil that is evaporate become mist vapor, and these are very flammable. So it's very important that all this accumulated fuel vapor inside the furnace, once it catch fire, you develop a very high pressure inside and causes an explosion. So it is usual practice that when there is a frequent flame failure, if the oil is not, the burner is not burning, and flame failure keep happening too often, the operators must go into manual mode to purge the boiler, the furnace space. That means to prevent any explosion. That means they purge by blowing out all this dangerous this vapor, and then you have to purge for a while before you can restart again to light up the boiler. So attempt to make the fire the boiler with insufficient purging time, and eventually will cause an explosion. So if you don't purge sufficiently out to the stack, you may cause an explosion because that is very flammable. So starting a boiler without purging the furnace, almost all boilers come with nowadays. In order to prevent all this happening, they have this automatic start and stop. So they run a program that the boiler will automatically do the purging, sufficient time to purge the furnace before they light up. So this program actually comprises of the program pre-purging and post-purging as well, before the burner is fired. So never isolate all these features, this if you need to run it manually, make sure that you pre-purge by means of the forced draft fan. This FD is called the forced draft fan for at least 2 minutes. Purge it for at least 2 minutes before you actually start up or light up the boiler. So if you avoid this step, you may cause a blowback or even explode. A blowback, you know what is a blowback? It's just a backfire. So yeah. So there's this video clip on they simulate a blowback. You take a look at this blowback.
Woo! Oh yeah. So the gas turned on, and then there was a delay, and it didn't light right away, and then when it lit, it came really far out. Okay.
Yeah, you can take a look, because this is actually what we call the blowback. When they fire up the boiler, there's a flashback.
Woo! Oh yeah. So the gas turned on, and then there was a delay, and it didn't light right away, and then when it lit, it came really far out. Okay.
So if this vapor can also cause a blowback, or even if it's too large, this vapor may cause an explosion as well. Yeah. So purging is like opening the window on the furnace to let the air in. It's required by the code, should be done before furnace heating start up or light up. You see a video, watch a video clips on this startup and light up. It's a purging process.
Hello and greetings to all. Today we will discuss about a very basic topic of boiler, that is boiler purge and its significance. First of all, we will see why boiler purge is required. Purge, as the name implies, is nothing but the cleaning of system before taking it into operation. Purging can be understood as scavenging of any system. It is simply cleaning of system before taking it into operation. With purging we clear off any residual unburnt fuel so as to avoid furnace explosion due to sudden burning of large amount of fuel at the time of light up. Significance of purging. Purging is the main permissive for boiler light up. As if purging is not done, then there will be no permissive for boiler light up. So permissive for boiler light up is purging. Boiler purging time is set at 5 minutes. Why this time is set at 5 minutes? This is because it ensures proper removal of unburnt fuel particles to be transported outside boiler furnace.
At least 2 minutes.
The procedure of boiler purging is clearly shown in this picture. Clean air is provided by forced draft fan or secondary air fan or FD air fan. This clean air is pumped into boiler furnace. At the other end, ID fan or induced dot fan creates a negative suction which pulls out this fresh air along with the unburned fuel and transport it to the stack or chimney. In this way, the unburned fuel is transported from boiler furnace to the atmosphere. As we all know, in power plant, for each and every operation there are certain permissives. Likewise, boiler purge also have some permissives. For ease of operation, we have divided these permissives into 4 major parts. The first major part is no boiler trip condition should be persisting. The second one is no fuel supply equipment should be running. Third one is no flame should be sensed by any flame scanner in boiler furnace. And fourth one is airflow should be greater than 30% and less than 40%. Further, in the upcoming slides, we will see description of each and every boiler purge permissive. The first condition among boiler purge permissive is no boiler trip condition should be persisting. Boiler trip, in other words, we can say MFT or master fuel trip. There are certain conditions due to which MFT occurs. Among these conditions are all I defense off, all F defense off, drum level high or low, airflow less than 30%, furnace pressure high or very low. If one or more of these conditions are persisting, then MFT will be true. In that case, we cannot go ahead with boiler purging. So before going for boiler purging, we have to normalize all these conditions. If you want any additional information regarding MFT, kindly refer to my another tutorial on master fuel trip. The second boiler purge permissive is no fuel supply equipment should be running. As we have already discussed that the main purpose of boiler purging is to remove unburned fuel from furnace. So any fuel supply equipment running or any fuel supply valve in open condition is not desirable. So to avoid that, we should have all LOTV and LONV in closed conditions. LOTV is nothing but light oil trip valve. LOTV is a single valve in LDO main supply line. LONV is light oil nozzle valve. This valve is provided at every corner before oil guns. Next, all HOTV and HONV should be in closed condition. HOTV is nothing but heavy oil trip valve. Like LOTV, HOTV is also a single valve which is provided in HFO main supply line. HONV is heavy oil nozzle valve. Like LONV, HONV is a valve which is provided at every corner before oil guns. Apart from this, the other conditions are all PA fan should be off, all cold feeders off, all mill hot air gates should be in closed position. The third boiler purge permissive is no flame should be sensed by flame scanner. The picture in this slide shows the location of flame scanner situated at every corner and at every elevation of boiler. This graphical representation is typically for 270 megawatt plant or 890 TPH ton of boiler. There may be more elevations in case if the boiler is for a 600 megawatt plant. So if any one of these flame scanner sends flame in boiler, then we will not get any permissive for boiler purging. Fourth boiler purge permissive condition is total airflow should be greater than 30% and less than 40%. This condition ensures adequate airflow inside boiler furnace, which is required to transfer unburned fuel to stack or chimney. As we have discussed earlier in previous slide, if airflow is less than 30%, then the MFT condition will be true. So if airflow is less than 30%, then we cannot go for boiler purging. So for boiler purging, it is required that airflow should be maintained above 30% and less than 40%. So friends, this is the complete logic of boiler purging. Through this logic, we can clearly understand the conditions and permissives of boiler purging. All these conditions are routed through an AND gate. This means all of these conditions are required to go for boiler purging. If any one of these conditions does not meet, then we cannot go for purge start. Once all of these conditions are true, then we can go for purge start. A 5-minute purging cycle will start and boiler will purge completely. In between this 5-minute cycle, during the time of purging, if any of this condition goes false, then in that case the purging will halt. In technical terms, if purge halts midway, then it is called as purge interrupt. In that case, we have to find out the condition due to which this purge interruption occurred. After finding out this cause, we have to clear this cause and normalize all the system. Then again we can start the purge from the point it was stopped. This picture clearly depicts the condition before purging and after boiler purging. Before boiler purging, MFT, that is master fuel trip, is in true condition. When MFT is in true state, then it does not allow boiler to be lighted up. Also, there will be no boiler protection in service, as already master fuel drip is persisting. After completion of 5 minutes of purge cycle, MFT resets. Now, as the MFT is not persisting, we can go ahead for boiler light up. All boiler protections are in service. We will discuss about boiler light up in my next tutorial on boiler light up. We will soon come up with more technical discussion videos in future.
So if you see the purging is a very important process which happen in lighting up the boiler. So just now I'm mentioning to you about the Shell refinery. There's engineer got killed. Most likely is that they do manual startup, and didn't do a proper purging. Then we have this boiler explosion. Maybe this is important, purging. So you can take a clip, watch a video clip on this boiler auxiliary, the boiler actual operation. Yeah.
To produce steam, you need heat. Plant boilers rely on the process of combustion to generate this heat. To generate heat and produce steam efficiently, boilers need the proper combustion equipment, devices like burners and stokers. Safe and cost-effective steam production also requires careful control of the various boiler flow paths. For example, boiler operators need to monitor and control air, water, and steam flow. The main function of all burners is the same: to inject a mixture of fuel and air into the boiler's combustion area. Burners are used with fuels that mix easily with air, such as natural gas, oil, or pulverized coal. This burner, for example, is a typical gas burner. It uses dampers or registers to regulate the amount of air entering the burner. Pipes called spuds inject natural gas into the boiler. This is an impeller. It's basically a stationary plate with openings, or vanes, that cause the air to swirl around and thoroughly mix with the gas. An igniter starts the gas-air mixture burning. This one has a sparking device that uses electrical current to create a spark across a pair of electrodes. The spark ignites the gas-air mixture. As it burns, it provides heat for the boiler. Like all fuel burners, oil burners provide a means to mix fuel and air for combustion, but there are some important ways in which oil burners are unique. This shows the major parts of a typical oil burner. Dampers control airflow into the burner. This is an impeller. It's basically a stationary plate with openings or vanes that cause the air to swirl around and thoroughly mix with the oil. Since oil's a liquid, it has to be changed into a mist, or atomized, before it can mix well with air and burn. This example is a mechanical atomizer. Mechanical atomizers depend on the pressure of oil passing through a nozzle to produce a fine mist. Fuel entering the atomizer flows to a sprayer head. The oil is forced through the nozzle, which breaks the oil into droplets. The droplets are sprayed into the combustion area in the form of a fine mist. Here's a type of atomizer that can use either steam or air to atomize oil. Steam or air flows through a tube and then to a nozzle in the sprayer head. Oil is supplied through the atomizer to the sprayer head, which directs the oil into the path of the high-velocity steam or air. This breaks the oil into a fog-like mist as it enters the combustion area. This action makes the oil easier to ignite and burn. To start the oil mist burning, there's an igniter. This igniter consists of a sparking device and a separate atomizer which serves as a pilot for the burner. A small amount of oil is sent to the igniter atomizer. The oil flows through a nozzle which creates the mist. The spark ignites the oil mist. After a flame is established at the igniter, oil flow to the main atomizer is started, producing an oil mist. Then the igniter flame ignites the oil mist and the combustion process begins. Some boilers are designed to burn solid lumps of coal. A device that supplies and burns lumps of coal is called a stoker. Stokers can also burn wood chips or other solid fuels as well. This stoker has a series of grates to hold the coal. A drive mechanism moves the grates through the combustion area of the boiler. The coal is stored in a hopper. A gate controls the amount of coal fed to the grates. As the coal moves along, air is forced up through the grates to provide the oxygen needed for combustion. The burning coal moves through the boiler's combustion area and supplies the heat needed to produce steam in the tubes surrounding the combustion area. Coal ash falls off the grates into an ash bin. In this topic, we saw the major types of boiler combustion equipment. We looked at gas burners, oil burners, and stokers. Let's take a minute now to try some practice questions. This burner, for example, is a typical gas burner. It uses dampers or registers to regulate the amount of air entering the burner. Pipes called spuds inject natural gas into the boiler. The airflow into a boiler provides oxygen for combustion. Gases produced during combustion flow out of the boiler and are discharged from the stack. The flow of air and other gases through a boiler is referred to as draft. The components typically used to provide draft are fans. There are two basic categories of draft fans: forced draft fans and induced draft fans. As their name implies, forced draft fans force air into the boiler. A forced draft fan draws air from outside the boiler and forces it through the burner into the combustion area. Induced draft fans create draft by drawing combustion gases from the boiler. Many boilers operate with only a forced draft fan. However, some boilers need both types to provide the proper draft. For example, in this boiler, the forced draft fan supplies air to the burner. Then, the induced draft fan draws out the hot combustion gases. The demand for steam from a boiler is called boiler load or steam load. When boiler load increases, more fuel must be burned to produce more steam. When boiler load decreases, less fuel must be burned. Changes in boiler load also require changes in the airflow to the boiler. The mixture of fuel and air supplied to a boiler is called the fuel-to-air ratio. It's important to maintain the proper fuel-to-air ratio to avoid combustion problems. For example, if the boiler is not getting enough air, some of the fuel entering the boiler won't burn. Instead, it may get carried out with the combustion gases and wasted. In some cases, unburned fuel could build up in the boiler. This buildup could cause an explosion if the fuel were ignited. In oil-fired boilers, unburned fuel may create soot deposits that coat boiler tube surfaces. Soot buildup interferes with heat transfer and reduces the boiler's ability to produce steam. In extreme cases, you may also see black smoke coming from the stack of an oil-burning boiler that's not getting enough air. On the other hand, if a boiler gets too much air, some of the fuel is used up to heat the extra air. This heat flows out of the boiler with the combustion gases. As a result, there's less heat available to produce steam. Most boiler operating procedures specify the proper fuel-to-air ratio. In addition, many boiler control systems automatically adjust the fuel and air mixture as boiler load changes. In some boilers, the air supplied to the combustion area is preheated. Preheating the air raises its temperature closer to the point where ignition occurs. This, in turn, helps to ensure efficient and complete combustion. One way to heat the air flowing into a boiler is with a rotary air heater, or preheater. This one consists of a series of heating surfaces, or elements, which are connected to a motor-driven shaft. The top half of this heater is in ductwork that routes hot combustion gases from the boiler through the air heater and on to the stack. The bottom half is in ductwork that directs incoming air through the heater and on to the boiler. A seal prevents hot combustion gases from mixing with the air flowing to the boiler. The heating surfaces rotate through the hot combustion gases. So, in this section, the heating surfaces are warmed by the hot gases. Then, the rotating heating surfaces transfer heat to the cooler air flowing to the boiler. The warmed air is sent to the boiler's combustion area. With this design, heat that would otherwise leave through the stack unused preheats the air entering the boiler, so the boiler operates more efficiently. The mixture of fuel and air supplied to a boiler is called the fuel-to-air ratio. It's important to maintain the proper fuel-to-air ratio to avoid combustion problems. For example, if the boiler is not getting enough air, some of the fuel entering the boiler won't burn. Instead, it may get carried out with the combustion gases and wasted. In some cases, unburned fuel could build up in the boiler. This buildup could cause an explosion if the fuel were ignited. One way to heat the air flowing into a boiler is with a rotary air heater. There's a feed water inlet and a steam outlet. The boiler illustrates how it works. The boiler has two drums. The upper drum is sometimes called a steam drum, and the lower drum is often called a mud drum. There's also a series of water tubes called risers, which carry a steam-water mixture to the steam drum. And this one has a downcomer, which carries water from the steam drum to the mud drum. Boilers normally have several downcomers. In addition, there's a feed water inlet and a steam outlet. The water tubes in the lower drum are filled with water. The steam drum is only partially filled. There's enough space in the steam drum to allow steam to collect. As combustion occurs, the water tubes that surround the combustion area heat up. As heat is transferred to the water in these tubes, the water becomes less dense and lighter than the cooler water elsewhere in the boiler. Some of this water turns to steam. As a result, the heavier, cooler water flows downward into the lower drum, and the lighter steam water mixture flows into the steam drum. Then, as the cooler water is heated, it too becomes lighter. It rises to the steam drum and is replaced by cooler, denser water. The steam flows to the plant through the steam outlet, and the water level is maintained by the water flowing through the feed water inlet. As long as combustion takes place, natural circulation continues. Not all water tube boilers rely on natural circulation. In some cases, a circulating water pump is used to produce the flow of water in a boiler. This type of circulation is called controlled or forced circulation. In this example, the pump draws water from the steam drum and forces it through the lower drum and the risers. As the water in the risers is heated, a steam water mixture is produced. Water from the pump forces the steam water mixture into the steam drum. If the pump circulates the water through the drums and the tubes, the boiler will operate as it's supposed to. Hypothetically, though, if the pump stops, the water will no longer circulate properly, and the boiler could boil dry and become damaged. To make sure there is proper water flow, most controlled circulation boilers use 2 or more pumps. So, even if one pump stops, the other pump will provide enough circulation to prevent damage to the tubes. With this type of water tube boiler, Water circulation depends on the differences in density between water and steam. Mechanical devices, such as pumps, are not needed. This method of circulation is called natural circulation. One way in which boilers are made more efficient is by heating the feed water before it enters the boiler. If the feed water is preheated, the boiler will require less fuel to produce steam. A device that's used to preheat feed water is an economizer. Economizers are often used in water tube boilers. An economizer is basically a series of water tubes located in the flow path of the combustion gases. Feed water is routed through the tubes on its way to the steam drum. The water is heated by the hot combustion gases flowing past the tubes. The economizer improves boiler efficiency by making use of heat in the combustion gases that would otherwise be wasted. The steam produced by a boiler generally contains some moisture. Some plant processes require relatively dry steam, so the moisture could be a problem. To prevent equipment damage from moisture, some boilers are equipped with moisture separators, devices that remove moisture from steam before it's sent to the plant. One type of moisture separator is a centrifugal separator, or cyclone separator, located in the steam drum. It works by directing the steam-water mixture into a circular chamber. The circular shape of the chamber causes the mixture to swirl around. The swirling action creates a centrifugal force. This force flings moisture droplets against the chamber walls. Then the droplets run back into the drum. The lighter steam flows out the top of the chamber. Some boilers use a dryer along with centrifugal separators. This design is often found in processes where extremely dry steam is required. This dryer consists of a series of V-shaped plates. The steam flowing through them has to make several changes in direction. The water droplets can't change direction as easily as the steam, so most of the droplets separate and drip back into the drum. The steam flows through the dryer and onto the plant. One type of moisture separator is a centrifugal separator, or cyclone separator, located in the steam drum. It works by directing the steam-water mixture into a circular chamber.
So there is some cock-up in the video clips. There's a repeating. So there is also this in the video clips about the drying of the steam to create. So this dryer that they use it is not going through a superheater. A superheater is, as I told you, is very dry steam, where the saturated steam is being so-called heated up until you remove all the moisture. Then this superheated steam is very, very hot and dry. So the next clip actually is a very old US Navy lighting up of boiler. It's a very old types of lighting up the boiler using a flame, you know. So just watch this for old time's sake, you know, how they light up those old boiler, you know, in the 1960s. You know.
Whenever you want clean drinking water, you'll have to boil the water, then wait for it to cool. What if you could...
So you can see this old method of lighting up the boiler. Yeah. Use a flame stick and all this, flame rods. But nowadays you won't find all this this traditional way of lighting up the boiler. So the other topics is how you clean up the boilers. So cleaning of the boiler, you have to never enter a boiler furnace space or until it's cooled down. That is logical. The furnace space is very hot. So you let it cool down before you enter into to clean up the boiler tubes. Every boiler furnace space or the boiler flue should be ventilated before enter. Then you got to do a manual purge, to pull up and ventilate it with all the draft fan and all this, or you have this exhaust fan to ventilate the boiler space, the furnace space before you enter. And make sure you have attendant standing outside the furnace space. When hand cleaning and scaling of the boiler, cleaning back, and you should use your protective when you clean up the burner space and the boiler tubes and all this. You must be using mask and or respirator or goggles, and to do the cleaning, because the suits that is inside the furnace space is very dirty, so you can't breathe it into your lungs. So there is a video on cleaning up the boiler, the fire side or the water side.
Subscribe now and press the bell icon. Never miss an update.
I watch them cleaning up the boiler tubes.
Destroy type 2 diabetes with our 6-second method or you don't pay for it. Top doctor from Arizona.
Welcome to the Boiling Point. We're with Stephen Taylor again, just carrying on from last week where we talked about the fire tube boiler. I thought, hey, let's go ahead and keep this going and we'll talk about the water tube boiler. And we just happen to have one back in our shop, of course, one of our rental units. Stephen, let's talk about the water tube boiler and how the actual gases and really just how it actually works. Okay, maybe take us through.
All right, get your burner sitting here. You can see the gas train on the front end here with the Maxon valves. Big wind box on these. The inside of the water tube is completely different than a fire tube. Fire tube, you have a round Morrison tube. In a water tube, you got a great big wide box, big rectangular box. It's, you know, this wide, this tall, the length of the boiler. So you have fire that comes out there. It goes down about 2/3 of the way down the firebox itself, and then it just gases, hot gases from there.
So the flame is actually about 2/3.
Flame's about 2/3 of the way down that firebox, correct. Okay. And then it touches the rear wall, the gases hit that rear wall, and they turn. On this one, this is an O-type boiler, so it's got a mud drum on the bottom, steam drum on top, tubes around the outside. So that fire comes down that firebox, hits the rear wall, turns, and comes between all those vertical tubes that are on both walls. Comes all the way back to the front of the boiler and then out the stack. That's how the gases escape.
Okay, now the real difference in a water tube and a fire tube is that the water is actually inside the tubes.
Inside the tubes instead of outside the tubes on a water tube. That's
so
correct.
the water's inside the tubes. Where's the steam?
If you look at that gauge glass up there, which is the two vertical pieces that have all the bolts on them, about 3 bolts up, that's where the water level is at in this water tube, which is about 1/3 of the way up that steam drum. So the rest of that big steam drum up there, you've got this much water in it, all the rest of it is what we call the steam disengaging area. So that's all steam in that steam drum.
Okay, and why don't you touch a little bit on the bottom drum, which is the mud drum, and what that really serves the purpose for.
Yeah, the mud drum is where all of the condensables, you know, any particulates that the water softener doesn't take out, chemicals that are solids, any of the solids that are in the water, they collect in the mud drum, and then periodically, typically once every 4 hours, once every 8 hours, it all depends on your water treatment. That is manually blown down, and that stuff is just flushed out and goes out into the sewer system or whatever system they have there to take care of that.
Now we've got different styles of water tube boilers. As you said, this was an O.
This is an O type.
But then we also have a D.
D type, and then you get up into a lot bigger boilers. You have A types, open bottom types for solid fuels. In the rental industry, the O type is by far the most prominent type out there, strictly because our center of gravity is the center of the boiler, so we don't have weight on one side. We can keep our dimensions small, and they make real good piece of equipment to move down the road.
And typical boilers that are stationary are going to have a little bit bigger firebox.
They're going to be a whole lot bigger firebox, more heating surface area, just everything's going to be bigger on the stationary unit.
We always talk about the rental boilers being hot rods on wheels, if you will. So. Well, let's talk, move maybe into some refractory. I mean, on a fire tube boiler, we talked refractory. What is actually inside the box here?
Very little refractory inside of these boilers anymore. We'll have a little bit of refractory on the mud drum, a little bit of refractory on the steam drum, and that's more to seal that area where all those tubes are coming into the drum, to seal that, where we have a gas seal. That's what that's for, and to protect that joint where that tube is going through the drum itself. We don't want to overheat that, so we make sure we protect that. And then the only other refractory we have in them, the rear wall is water wall, both side walls are water wall, floor and the ceiling. Most of the front walls are water wall. We have refractory right around the burner itself, so it's going to be, 3 feet, 4 foot square. That's all the refractory that's in the walls of the boiler at all.
What's actually keeping the heat from just destroying the outside of these
coming through the
skin
sides.
here.
Those interior walls have ligaments on them, and those ligaments are welded solid to the tube, and then that ligament is welded. They're welded solid to one another, so that you have a 100% sealed wall. The only way the gases can go is either one of those breaks, and the other way is it goes around the back and comes around the way it's supposed to, so you get the proper heat transfer.
Right. Now, obviously, we talked a little bit about the fire tube last episode. Why are we going to use a water tube boiler?
Because the footprint of the water tube to get the same capacity is a lot smaller, and that's in essence that's what it is. I mean, this is a 60,000 pound per hour boiler. This happens to be a 550 pound design unit. To get a 60,000 pound fire tube with this kind of pressure, it would be twice that long and 15, 18 foot wide. It'd be a huge piece that you have to move by rail. You couldn't even move that up and down the road.
Well, Stephen, what about pressures on a water tube boiler? Tell me the varying pressures on a water tube.
Standard pressure on a water tube is 250. These rental units are 350. This one happened to be 550. It's a specialized unit. Water tubes are typically a lot higher pressure because, you know, you think about it, you take a 2-inch tube and you put 350 pounds in it. It's a lot easier to control that, a lot thinner metal than if you have a diameter of 10-foot diameter shell, then the metal gets that thick in order to hold the same pressure. That's the reason anytime you go into high pressure, you're going to be in a water tube type boiler.
Give us some real exotic pressures of really what's out there. I mean, I think that's
Oh, there's,
interesting.
you know, supercriticals, 2,400 PSI, 2,600 PSI, 2,000 degree superheat. Those are supercritical for power plants and that type of thing.
Right. Big as a house, though.
Big,
I mean, it's massive,
yeah,
bigger than houses.
Yeah, 10 stories tall, just huge piece of equipment.
Right. How about temperatures inside the boiler? What are we
Inside the firebox itself, we're still going to be in the same general temperatures we are with the fire tube. The thing we want to do is keep that flame temperature below 2,500 degrees. Above 2,500 is where you start forming thermal NOx, which is strictly the nitrogen from the makeup air. When it mixes and gets above 2,500, it starts creating NOx. So we want to stage that flame and keep that temperature below that 2,500. So we'd like to be in that 2350 on the flame. When you get to the rear wall, again, you're going to be back down to that 16, 17, 1,800 degrees.
Well, there you have it. I've got a simple explanation about a water tube boiler from Stephen. We've talked about the fire tube. Now we've got the water tube. Make sure you go back in several issues. I know we were inside of this water tube boiler on one of the boiling points that we've done, and you can really see what's inside there. So we'll see you next time on the boiling point. Well, appreciate Stephen stopping by with us. A real simple explanation about the water tube boiler. You can see in the background of how many different boilers that we have, a lot of different sizes, whether it's fire tube or water tube, from 50 horsepower all the way up to 150,000 pound-an-hour from a rental standpoint that we've actually got here. So make sure that you come by and see us at Power Gen coming up in December.
Yeah, you see the more common is the water tube boiler, which is more common than the fire tubes. See, fire tubes are actually with the same capacity. The fire tubes are much bigger, you know. So it's water tube is a bit more compact with the kind of capacity we're looking at it. So we talk about gauge glasses. You know, there's 2 gauge glasses. Just now you saw that. So there is a blowdown procedure for the water level gauge. You look at this video, how they do the blowdown of this water level.
Proper maintenance of water level instruments on a boiler is crucial to keeping your plant running safely and efficiently at all times. We're going to demonstrate how to conduct a proper blowdown procedure on a boiler water gauge glass and a remote level indicator. But first, let's understand the purpose of these vital level indicating instruments. The water gauge glass on a boiler enables the operator to visually observe and verify the actual water level in the boiler. However, if not properly cleaned and maintained, a gauge glass can seem to show that there is sufficient water, when the boiler is actually operating in a low or low water condition. Lack of maintenance may result in a stain or coating on the inside of the gauge glass where it is in contact with the boiler water and give the appearance of an incorrect level indication, especially if the drum level happens to be outside the range of the level instrument. Be sure that all plant procedures have been followed, and the control room operator is aware that a blowdown of the level instrument is about to take place. This will prevent any false trip of the boiler or unexpected drop with level indication for the primary control operator. Before conducting this procedure, inspect the installation. If any leakage is observed around the instrument or isolation valves, determine the source of the leak and make the repair. Then proceed with this blowdown procedure. The importance of proper cleaning and maintenance of the water column and the water gauge glass or level indicator cannot be stressed enough. The water column and connecting piping must be kept clean to ensure the water level in the gauge glass accurately represents the water level in the boiler. The frequency and method used to blow down a level instrument may affect service life and performance of the water column, gauge glass, or level indicator. At a minimum, we suggest weekly blowdowns on gauge glasses and monthly blowdowns for level indicators, with a maximum duration of 20 seconds. Excessive duration of blowdown time will shorten the life of the gauge glass or level indicator. However, plant rules will determine the actual frequency required. The user may also consider the quality of their boiler water as an influencing factor to determine the blowdown frequency. Furthermore, operators must consider proper blowdown procedures in order to keep the connecting water piping clean, even if the glass or level sensors remain clean for extended operational periods. Simply opening and closing the drain valve on a level instrument to conduct a blowdown will not ensure that water is flowing freely from the boiler drum through the water piping to the level instrument. However, by conducting the blowdown in this manner, the water that is in the instrument will drop and go out the drain, but there is no assurance the water leg piping between the boiler drum and the level instrument has been flushed. This is because the steam and water are both flowing from the outlet of the open drain. By following this procedure, the operator will ensure that steam and water both flow freely in this piping by testing them independently. The intent of this part of the procedure is to remove any debris or sediment from the water leg piping. While the risk of developing a blockage in the steam piping is very low, the risk for sediment buildup in the water piping is much greater over time. After following the blowdown procedure for a gauge glass or remote level indicator, the operator can be assured the steam and water connecting piping will be thoroughly flushed. We will now describe the recommended procedure for blowing down water level indicating instruments on a power boiler that's been constructed to meet the requirements of the ASME Boiler and Pressure Vessel Code. Please note, isolation valves between the drum and the water column, number 1 and number 3, are optional by code. However, if they are installed, they must be locked open under normal operating conditions. The drain valve number 5 on the water column is required by code. Using this drain valve alone is not a sufficient method to flush all the steam and water piping. This valve will remain closed during the following procedure. To begin the blowdown procedure, close the steam valves number 1 and number 2. Next, with water valves number 3 and number 4 in the open position, open the drain valve number 6 and the water will discharge. Water will be flashing due to the elevated temperature. This discharge from the water leg piping should be observed flowing out of the drain. The drain must be routed to a safe location, away from the operator. The drain piping may be routed to a condensate tank or a location away from the instrument, which may require a second individual in order to validate the flow. After 20 seconds, close the water valves number 3 and number 4. Then, open the steam valves number 1 and number 2, leaving the drain valve number 6 open. Steam will flow through the gauge glass and the drain valve outlet. After an additional 20 seconds, close the drain valve number 6 and open the water valves number 3 and number 4. The blowdown procedure for a gauge glass configuration has been completed, and the indicated water level should promptly return. If the water level does not promptly return to normal, the connecting piping may be partially clogged and need to be physically cleaned. To begin the blowdown procedure for a power boiler configured with a remote level indicator, first, close the steam valve number 1. Next, with water valve number 2 in the open position, open drain valve number 3, and the water will discharge. After 20 seconds, close the water valve number 2. Then, open steam valve number 1, and steam will blow through the remote level indicator and the drain valve outlet. After an additional 20 seconds, close the drain valve number 3 and open the water valve number 2. The blowdown procedure for a remote level indicator has been completed, and the indicated water level should promptly return. If the water level does not promptly return to normal, the connecting piping may be partially clogged and need to be physically cleaned. Finally, as an important safety tip, operate all of these valves slowly. This enables the operator to carefully observe the valves and instrument while conducting this procedure.
So you have seen this going down for the gauge class. There is also if you need to clean up the boiler or shut down the boiler, there is also this blow down for the whole boiler. You know, remember the picture on this boiler. There is a blow down valve. This blow down valve is not for the gauges. You know, it's actually to blow down to shut down the boiler for repairs or maintenance or cleaning. You will use this blow down valve, and it will just remove all this water and steam out of this boiler. Of course, when you do this blow down, basically the boiler is actually shut down. You know, there is no more, the burner is fired up, it stops and all this, and the remaining pressure in the steam and the water can use it to blow down the whole boiler. Yeah. So we come to this exercise on give one of the most important cause of the boiler blowback. Why is it the boiler blowback? Anyone want to try this?
Oil vapor.
Yeah, it's excessive oil vapor that is in the furnace space, you know. And then when you start it up, you know, you ignite, it flash back. You know. So the light the burner with the oil vapor in the furnace, you know, it will cause a big backfire or called blowback. So before I change any faulty fitting on the running boiler, what must I do?
Off the boiler.
Before you actually take out the safety valve or take out any of the valve, you know, feed valve and all this. So firstly, the most important is to shut down the boiler, you know. Then after that, you shut down the boiler, you blow it down, blow down the whole boiler. Then you close the steam valve, main stop valve. Then wait for the boiler to cool down before you actually doing any of this maintenance work or repairs or changing any valve fittings and on boiler fittings or mounting. So important thing is these are the and I think at this time I do not want to start the fire safety because it's almost 5 o'clock. We will stop and then fire safety we will start tomorrow morning. We go to fire safety. Any question you would like to ask, or you can bring out for discussion and all this regarding about this.
So far, so good.
So far, okay. And I think before I supposed to take a screenshot before we leave this Zoom, but the screenshot I don't want it to take. I was told to take at 5 o'clock. You know? So we got about five more minutes before we take a screenshot. You know? Yeah. So if there's any question, you can just or anything that you need to clarify and all this, and we can bring it out and then you can discuss it, because it's quite a long day, you know.
Yep.
It's a long day where we everybody can get a bit tired now. Yeah. So what we should do now, another 4 more minutes
Yeah.
before I take any screenshot. Yeah, do some exercise. You know, your neck and all this get a bit of tired, you know, neck. Yeah. So tomorrow morning, Fidas is going for the swab, right?
Yes, I am.
Yeah, around what?
10:45.
Okay.
Yeah.
10:45, and then Ku will be on Friday. Ramza, what time is it?
On Wednesday, we'll go maybe
Wednesday.
1 hour before lunch.
Okay, so it's about 11 now. Yeah, you can leave
11
about 11. Yeah. So, Fahmi, are you going for the swab?
Mine is on Sunday.
Oh, Sunday. Okay.
Yeah,
Okay.
every Sunday.
Every Sunday. Yeah.
Mm-mm.
Yeah, actually, you can change your date, right? I don't know. So far
We can change, but for me now, if I change, I still got stuck one day.
Yeah, that's right. Mine is on Sunday also, so every Sunday I will go for the swab. Yeah.
Because the ART, we have to go see doctor.
ART, I thought now you can do it on your own, right?
Because my company have not registered yet. I haven't sent anyone.
Okay.
Yeah.
You need to be registered, then you can company can do it.
Yeah, they are arranging now. I don't know when.
Then you can actually what do you call upload into your health hub, right?
Yes.
Yeah. All your health hub will have all the result of your tests, you know.
Correct.
Your PCR test.
Actually, I want Yat to do for me, but the Yat said, "Oh no, they don't want to take any risk."
But if you do it on your own, you got to buy your own self-test kit.
Yes.
Yeah. I have never do it on my own.
On Saturday, I'll go.
Yeah. Okay, I would just take a screenshot on.
Smiley face,
Yeah. You need to smile, yeah.
Yeah. Just to throw all the tiredness.
Yeah. Okay, actually, now it's about 1:05 lah. Yeah. For you, actually, you can lock off lah now. But for me, I'll wait for a while until after 5 minutes or 1 minute after 5, then I'll shut it down. So for
now
you,
exactly 5, yeah. Okay, lah.
yeah, you can shut it down and then go home and have a nice
Tomorrow same
lunch.
time, 9 o'clock or 8:45?
Yeah. 9 o'clock lah. We started at 9 o'clock, but I would probably start the Zoom maybe about 5 minutes before 9. Yeah.
Okay.
Then you can just come in at 9. Oh.
Okay.
Okay.
Yes, okay, bye.
Have a nice day.
Thank you very much.
Well,
Thank you.
thank you.
Okay, thank you.
Bye.